Hello and welcome back to another video. In this problem, we're asked some questions about the function of the absolute value of x. So in part A, we're asked how is the graph of y is equal to f of the absolute value of x related to the graph of f. So I think the best way to do this is to visualize it, right? So we have our xy plane, and let's just have some function like that. If we're taking y equals f of x, it's going to look like this. What happens when we do y is equal to f of the absolute value of x? Well, the absolute value of x is going to make something positive. So if x is positive, this is just f of x, and this stays the exact same. However, if x is negative, then we are taking f of the positive equivalent. So the value of this point on f of the absolute value of x is the equivalent over here in the positive direction. So it's actually going to mirror it like that. We completely eliminate this other part in the negative. So how is the graph related? You take the positive section, the x being positive section, and you mirror it across the y-axis. You reflect it over the y-axis. Because those negative values, which used to be different, are now just the exact same because they are made positive by the absolute value. So let's take a look. B, sketch the graph of y is equal to sine of x. We have our graph here. We have pi, 2 pi, 1, negative 1. Now, we'll make that negative 2. That negative 1 is way too far. The positive side of the graph, remember, we don't have to touch. So that starts at 0, it goes up to 1, back down to 0, to negative 1, and back to 2 pi. And normally, the sine of x, I'll draw it as a dotted line, would go something like that, right? It goes negative, then it completes the cycle periodically, but it's going negative before it goes positive. However, we are mirroring this, so it's instead going to go positive to mirror this section, and then it goes negative to mirror the other section. Same thing here. The graph of y is equal to the square root of the absolute value of x. Now, the absolute value of the square root of x as a function looks something like this. And that is the only part of it. There's no negative x part of it because you can't take the square root of a negative number. So even though there's nothing to replace like we had over here, or with the sine function, there is still going to be something added over here, which is a perfect reflection, if I can draw it right, of the positive side. Because now if we take the square root of negative 4, we're taking the absolute value, so now it's the square root of 4, so it's positive 2. So once again, we just match it by mirroring the positive side over the y-axis onto the negative side.